Hi everyone, this is Mr. Hall and this is a video on how to balance equation using moles. 99% of the time you'll be able to balance equations using the old-fashioned way where you determine the number of atoms on the left and the right of an equation, then through some deduction you'll be able to work out the balance equation and the coefficients that go with it. You can also do it by using moles, and it's quite an obscure way and it's quite a strange thing to be in some specifications, in particular AQA in this instance, but it's something you do need to know. It's clearly in the spec. So it's worth knowing. So the objectives for today are to calculate moles from mass data, which you should know, and also to balance an equation using the masses of reactants and products. Now let's start with just how you would normally balance an equation. Now most of the time, balancing an equation is pretty straightforward, where you work out the number of atoms on the left, the number of atoms on the right, and then through deduction you'll be able to work out what the balanced equation is. In this case, if I was to do it, I'd work out that magnesium and oxygen, hydrogen, and chlorine are the four atoms in this equation. For magnesium, there's one on the left, one on the right. Oxygen, I've got one lot of two, which is two on the left. I've got one over here, so there's one on the right. Hydrogen, there is two on the left. Oh, no, actually, it's three on the left, I should say. And there's two on the right. And then for chlorine, there's one on the left, and there's two on the right. So the first thing which I'd be tempted to do is to balance my chlorines out. So to do that, I need to put a 2 in front of here. And because I've done that, I now have two chlorines which are balanced. And for hydrogen, I've now got these two and two here, which now gives me 4. I would now be tempted to balance my hydrogens, where I would put a 2 here. And I've got two lots of 2 hydrogen, which is now 4. And then oxygen, I've got two lots of 1, which is now 2. And then everything is balanced out. Now that is the traditional way of balancing. It works absolutely well. There's no problems with it. There is, however, an alternative way if you're given the right information. So let's have a look at the equation again, but from a slightly different perspective. Now these are the steps that you would do to balance it if you had mass data. So the first thing you do is you divide the mass by the MR for that substance to calculate the number of moles for each. And then the second step is that you divide each number of moles by the smallest one to determine the ratio. And then with the ratio, you use those in order to determine what the coefficients are. Now, I like doing all my working in tables because I think it kind of keeps everything nice and tidy. You may choose to do that, you may not. It doesn't really matter as long as it works for you in terms of the organization of your ideas. Whichever one you choose to do, always show your working. So if we look at this first one, first off, I want to work out the step 1. So I need MR information to work out the moles and doing the division by the mass. So my MR for MgOH2 is 24 and it's 2 lots, because of this 2, of 16 plus 1, which is basically 17. So it's 2 lots of 17, which is 34, 44, 54, and that's 58. Sorry, not 40, it's 58. The MR for HCl is 1 plus 35.5, which is 36.5. Your period table might just show 35, particularly for AQA, but really it's 35.5. For MgCl2, it's 24, add 2 lots of 35.5. So that's 71, and that's 95 in total. And then for H2O, it's 16 plus 1 plus 1, which equals 18. And notice I've shown my working for MR. It's amazing how many students skip this step of showing the MR for, or the working for MR, and then they lose loads of marks for the rest of it because they didn't double check their answer and they didn't show their working to get the marking for there too. Now for moles, it's mass divided by MR, so it's 2.9 divided by 58, and that gives me, if I just put it in my calculator, 2.9 divided by 58, and that gives me 0.05. If I look at the next one, I do mass divided by MR. Just remember, I'll write the equation here. Mass, or moles rather, is the same as mass divided by MR. And this is the central equation that will guide you through these problems. So for this one, it's 3.65 divided by 36.5, which will be 0.1 if you put it in your calculator. 4.75, this is my mass, divided by the MR here, which is 95. That gives me 0.05. And then here, 1.80 divided by 18 gives me 0.1. Now I've done step 1. I've now got to do step 2, which is divide each number of moles by the smallest one. Now the smallest mole out of all of this is 0.05, which is incidentally repeated twice. So for this case, I divided by itself. So 0.05 divided by 0.05 equals 1. And I can do the same over here just to kind of make that shortcut happen. Notice I'm always showing my working. Here it's 0.1 divided by the smallest, which is 0.05, which gives me the number 2. And that's the same over here. The last step, I've done this one, is to say that the molar ratio is equal to the coefficients in the equation. So this is going to be my coefficients. So I've got one lot of MgOH2. Now, because I've only got one, I leave that blank. Here, I've got two lots of HCl. I put a 2 there. Here, I've got one lot of MgCl2. Leave it blank. Here, two lots of H2O. I put the 2 there. And if you look at that carefully, and if you rewind to the what I showed you before, I've got exactly the same coefficients, which is great if you look at what I did here. Okay, so let's try with another example, maybe a little bit more complicated. Here I've got aluminium reacting with sulfuric acid to create aluminium sulfate and hydrogen. Now the steps I'm going to use are exactly the same. We've got slightly more complicated formulae, but you'll notice that however complicated it is, the steps are exactly the same. So the first thing I need to work out moles, but to do that, remember moles equals mass divided by MR. So to do that, I need to first off work out the MR. For aluminium, it's 27, pretty straightforward. For H2SO4, a little bit complicated. So 2 lots of hydrogen, that's 2. I add sulfur, which is 32. And then I add 4 lots of oxygen, which is 16 times 4, which is basically 64. So 64 plus 32 plus 2, and that gives me 98. I then have to work out the MR for this. Now, this is an absolute beast, so we're going to take this one step at a time. First off, I've got 2 lots of aluminium, which is 2 times 27. I've then got 3 lots of everything in this bracket. Now, if I've got 3 lots of 1 sulfur, that'll be 3 lots of 32. And I've also got 3 lots of 4 lots of oxygen. So 4 times 3 is 12. So I've got 12 lots of 16. So 12 times 16. Now, if I put all that together, that's 2 times 27, which is 54, plus 3 lots of 32, which is 96, and add to that 12 lots of 16, and that gives me a rather large number, which is 342. Huge number. And then I've got hydrogen, which is 1 times 2, and that equals 2. So now let's work out the moles. Now remember, moles is mass divided by MR, so it's 108 here, that's my mass, divided by 27, and that gives me, I believe, 4. Over here, I've got 588 divided by 98, and that gives me 6. Here, I've got 342 divided, oh no, sorry, that's wrong, 684 divided by 342, which I believe is 2. And then here it's 12 divided by 2, and that gives me 6. Now, what I now do is I've done my first step. The second step is to divide each number of moles by the smallest one. Now, my smallest mole is the number 2. So let's try that out. So here I've got 4 divided by 2, which equals 2. Here, 6 divided by 2 equals 3. Here, 2 divided by itself, which equals 1. Here, 6 divided by 2 equals 3. So if I was to put these now as the coefficients, I would have a 2 here, I'd have a 3 here. This would be 1, which I'm going to leave, and this is a 3, which goes there. Now, if you really want, you might want to just double check your balancing to make sure it works, but I'm pretty sure it's going to work. If we look at aluminium, 2 over here, 2 over here, that works. Hydrogen, 3 lots of 2 is 6, 3 lots of 2, 6, good. Sulfur, 3 lots of 1, fine. Here, I've got 1 in the bracket, but there's 3 lots of those brackets, so it's 3 in total, that also balances. And then for oxygen, 4 times 3 is 12. Here, 4 times 3 is 12, also works. So you can see that it works perfectly. And I'm going to show one more example to you, which is a little bit harder. Here are the steps, because you might have to do an extra step with your ratios. So let's have a look at this. So the first step, as before, remember moles equals mass divided by MR. I have to first off work out the MRs. Now the easy ones is carbon, which is 12, and Fe, which is 56. For Fe2O3, it's 2 lots of 56, because that's the AR for oxygen, for iron rather, and I add that to 3 lots of 16, which is for iron, and that is 160 in total. And then over here, it's 12 plus 2 lots of 16, and that gives you 44. So to work out the moles, it's mass divided by MR. So 64 divided by 160, and that gives me, if I put in my calculator very quickly, 0.4. For here, it's 7.2, that's my mass, divided by 12, and that gives me 0.6. For this one, it's 44.8 divided by 56, and that gives me 0.8. And then for the last one, it's 26.4 divided by 44, and that gives me 0.6. So I've done my first step. Step 2, I need to divide each one by the smallest number. If I look at each of them, my smallest number is the 0.4. So here I divide it by itself, which gives me 1. Over here it's 0.6 divided by 0.4, which gives me 1.5. Here 0.8 divided by 0.4 gives me 2. And over here 0.6 divided by 0.4 again gives me 1.5. Now at this stage we could put all these numbers for step 3 as being the coefficients, but you'll notice we have a problem in that we have some decimals. Now ideally you try to avoid decimals, and one of the easiest way of avoiding decimals is simply to double all the numbers up. So for this one I want to double it up, which is times them by 2, so 1 times 2 is 2. Over here I need to double up my 1.5, so that will give me 3. Here I need to double up my 2, which will give me 4, and then this 1.5 I double up times by 2, and that gives me 3. Now I have whole numbers, I have integers, and I can use those as the coefficients in my balanced equation. So that would be a 2, because that's what that is. This 3 goes up here to form 3. This 4 is used here to be 4, and that 3 slots in here to be 3. And again, we can do a quick check just to double check we haven't made any errors. Iron, I've got 2 lots of 2, which is 4. Here, I've got 4 already, all balanced. For oxygen, 2 lots of 3, which is 6. Oxygen, 2 lots of 3 is 6. Oxygen is balanced. And then finally carbon, 3 lots of carbon over here, and over here 3 lots of carbon as well. So that's balanced too. So you can see that this technique, it's, as I said, it's quite rare that you'll ever get a question on this, but it is very powerful, but it does require you to be able to be good with your mole calculations. And that's it. So I hope that was useful, and best of luck with your balancing using moles.